Why is 5G 5G? It's the fifth generation in the evolution of mobile telecommunications, but what does that mean? Let's look at another evolution. We have given different stages in the evolution of man names, just like version numbers. Similarly, we've had an evolution of mobile technology since the 1980s, and we have versioning here as well, although we call the versions generations. Typically, much like with versions, every new generation brings with it something new. The first generation was analog, and the second digital, promising better audio quality. Much like the natural evolution of man and differences between species, there is no exact definition of what or how much needs to change for us to talk about a new mobile generation. There may be a fossil found between version 2 and 3 of man, and we'll say it's late version 2 or early version 3. Exactly this happened in the mobile generations, where the possibility of IP data connections was introduced in the middle of the second generation. This technology was called GPRS, and it was often referred to as 2.5G or even 2.75G. After GPRS, 3G came along and gave us faster mobile data speeds. 4G increased these speeds even further, and 5G gave us even higher bit rates, plus other valuable improvements for the mobile operators. Can we learn anything from history? Well, when 2G was launched, it was digital, which enabled higher quality voice calls. The most groundbreaking application of 2G, or killer app, wasn't that though. It was text messaging, something no one saw coming. Let's continue and compare promises and killer apps in the other generations. 3G promised video calls. This didn't happen at all. Instead, it gave users functioning mobile access to the internet. 4G promised mobile broadband, and it has been used for that. Still, the big end-user application has been streaming video like YouTube or Instagram. So what about 5G? Well, it gives us a vision of smart cities and advanced remote surgery, and these things may become real, but what we can learn from history is that it's challenging to learn from history. We simply don't yet know what the most impactful 5G service will be.
And if you look at slide number 3 over here, these are the original 5G use cases that I would like to start with over here. It's a well-known picture with a triangle where we say the telecom system that we are designing will have to be able to handle applications that have certain characteristics. And originally we found 3 groups of applications that need to be addressed. This group of applications, they are the ones that require high throughputs. This is their focus. They are going to need enhanced mobile broadband. You can see some examples here: 3D video, ultra high definition screens, augmented reality, and the voice service that is used by people, telephony service, also falls into this group. Then another set of needs over here: smart home, smart building, smart city. This is what we refer to as, I used the term IoT earlier, Internet of Things. This is the machine type communication. The main challenge here, as we said, is that there is so many of them. So massive machine type communication is another bunch of applications that we will want to handle within the 5G system. With this triangle is the original 5G use cases, and as time proceeded, we managed actually to figure out that there is a group that needs to be kind of taken out of here that has special needs that make them slightly different to cater for. The so-called high-performance machine-type communication means that some of the applications in this group, they will actually need high throughputs, and therefore they should be treated differently than the original IoT devices that we were analyzing when the original triangle was built. And then the third part of the triangle over here, as I call them, the ORCs, URLLC, ultra reliable and low latency communication. These are applications that require either very high reliability or low latencies, or in the worst case, both when it comes to quality of service. industry automation, mission critical applications are here, and self-driving cars, which again over time got taken out of their original category and they got their own category defined. The V2X is now one of the 5G use cases as opposed to the original when we had actually 3 of them. And the idea is going to be that when we are designing the 5G system, we will keep in mind that we would like to be able to carry a variety of applications with the different requirements that they have, different from one another, on a physical network that is no longer following this rule of one size fits all.